Oh. What's happening? Hello. Uh-oh. Wait. Here. It says there's in there. Hold on, let me try again. Hello. Oh, you can hear me. Can you guys see me or no? Sorry, there is something going on. The live stream said there's an error in the playback. What is going on here? Hold on one second. Let me just look on my phone and make sure this is working. Oh, it is working. Okay, never mind. So I don't know if you can see this on my screen. It says error for some reason. Can you guys see? All right. So I think this is cool. Sorry, there is something. I think this is cool. It's all good. All right. That's it. We're gonna just hit it and we're gonna roll and let's hope everything goes. Let's hope this uploads and all that. But I think it should be all right. I don't know what this is going on here, but I'm not going to worry about it. So what's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And we got a big audience today, which is pretty cool. By the way, I just want to blast out on Discord that we're going live right now as well. And if you haven't joined our Discord community, you can. The link is in the description below. It's totally free. It's awesome. You'll get to know all sorts of information like when I'm streaming, because that's what I'm going to do right now. I'm going to blast it out there. And you can also connect with a lot of other students. Let me just post this. Boom. Let everybody know. But yeah, you can post with other students who are studying for the test and form study groups. I know people are helping each other out, so it's really, really cool community if you want to check that out. So anyways, today we are doing a big review, and the review is going to be two parts. It's going to be, first we're going to be talking about these 7 strategies that I've created and gone over that are super important. That can right off the bat boost your score a bunch if you're not doing them or if you're only doing a couple of them. Wait, who says you can't hear me? Sorry. Okay, yeah. I just want to make sure. Niket Patel says you can't hear me. I want to make sure I think the audio is still working. But anyways, so we're going to go through these tips. They're very, very important. Then after that, we're going to go through the 23, what is it? I think it's 23 formulas, right? We're going to go through the 23 formulas that I've identified that I think are super, super, super essential and important for you guys to study. All right, so here we go. Let's go through these tips. And here we go. All right, so tip number 1 is underline the last part of every question. So in this tip is very important for certain types of questions in particular. So if we look at this question, right, you see it's a proportion, 5 over x equals 15 over x plus 20. You might be like, all right, cool. I'm going to just cross multiply, do my thing, isolate, and then what do you have? You might have solved for x, but that's not what they're asking for, right? So you notice if you underline here, you'd be like, oh yeah, I got to remember that at the end, we're solving for x over 5. And in this case, let me just calculate it real quick. What is it again? 1530. Yeah, so the answer for x is 10, right? Because if you plug 10 in, you get 5 over 10 equals 15 over 30, half, boom, done. But they want x over 5, which is 10 over 5, which is actually c, and that's 2. Here's another example, right? They've got this equation. They spell it out. 16 plus 4x is 10 more than 14. What is the value of 8x? Again, we're not solving for x. We're solving for 8x. So that's very important. Underline the last part of the question. Okay. Number 2, know your formulas. And this is going to come into the section where we're going to go over all of the formulas here. So check this out. The reason why one of the things that you have to know is what formulas you're given, so that way you can know what you need to know. So the formulas that you're given are at the beginning of both the calculator and no calculator section. It's on this reference sheet. So what you can see is you can see area, circumference of a circle, area of a rectangle, a lot of area formulas. We also have special right triangles. We also have Pythagorean's theorem. And then we have these volume formulas. The one thing that they don't have is the volume for just like a general prism. Actually, well, they do because it's a rectangular prism. But for a triangular prism or other types of prisms, again, just because they have been testing on this a little bit more lately, these triangular prisms or any other prism, it's the same thing. You take the area of that triangle, that shape that's extended backwards by the height, and you multiply it by the height. Boom, done. All right. And then the other formulas here, these are the 23 formulas that I'm going to be going over later in depth. But if you want to take a quick screenshot, I don't know if this is totally clear right now. It's kind of, small on the presentation. But we're going to get into the presentation. Everything's going to be much bigger and more visible. All right. Tip number 3, answer interpretation questions before looking at choices. So, hey, what's up from Ethiopia? So if we look at an example like this, right? So a lot of people will often read the question, look through the choices, and then go back and apply it to the graph. What I like to do, and what I highly recommend, really get your head around this question before even looking at the answer choices and understand that graph. So for example, it says, the graph above displays the total cost in dollars of renting a boat for 8 hours. So you're going to look through, you're going to be like, all right, this is total cost here, this is per time, and then look at the difference in the markings, right? 4 of these spaces is 1 here, 1 of these spaces is 1. So anyways, it's a really important thing to do, and I'm telling you, it makes a big difference on some of these more difficult, more lengthy questions. Okay. So another one like this, if you look at this wheel spinning around and, what is that, what's happening with the dot? It says the wheel is rolling on the ground at a constant rate along a level straight path from a starting point to an ending point. The graph could represent which of the following? So what I would do is I would look at this and be like, all right, what is happening? It's going up, down, up, down, up, down. Well, that to me looks like the position of that little dot, right? Because as the wheel goes around, it's going to go down, then back up, down, then back up. And that's what the graph looks like. So I've already got in my mind that's probably what it is. What's up from Nigeria? What's up from Qatar? It's amazing. And then we go through and now we look through the choices. The distance the wheel is not from the starting point, not the speed at which it's rolling, but D, the distance of the mark on the rim from the ground. Boom, done. Okay. All right, tip number 4, utilize multiple strategies. Okay, so we've got a bunch of things in our toolbox, if you will, when we're taking this test. And I always like to emphasize for my students, hey, I want you to know all the different ways, all the different angles in terms of solving this. Not necessarily, doesn't have to be the best, fastest, most efficient, perfect way, but I want you to know multiple ways to do it. And then the best one, the most efficient one, is what comes to your mind, right? Even if you know how to solve something algebraically, but you can do it faster by plugging in answer choices. You solve it algebraically, you solve it. It's still going to be pretty fast as long as you've had the right amount of practice and all that stuff. So that's what this is about. First, standard math analysis, right? Straight up algebra, whatever you may need. Number 2, plug and chug. That's one where you take answer choices that are purported to be the right answer. You plug them into the equation or whatever it is, and you go through and you can solve like that. Number 3, making a table. This is such a huge tip. You can make a table, especially with exponential functions when you're trying to map it to a graph or things like that. Makes a huge difference. Also, when you're trying to create a linear equation from data points, et cetera, et cetera. Okay, so those would be my main ways to approach each problem. Excuse me. Number 5, check every answer immediately. Of course, you can come back and check your answers at the end, right? I think we all do that. But I always want to move forward with a lot of confidence. Even if I'm pretty sure I've solved something correctly, I can check it right away. And then I'm like, all right, now I don't have to worry. So for example, in this one, right, we got which of the following equations relates y to x? Let's say we go through the whole process. We do our thing. We're good, right? we've got 7/2 x minus 3/4 represents this. But now I can plug in a little bit, right? So let's plug in a few and check this. If I plug in 1, that's 7/2 minus 3/4. That's the same as 14/4 minus 3/4, which is 11/4. Boom. Now, but that's only one value. You got to check at least 2. Now I plug in 2. I get 14 over 2, which is 28 over 4 minus 3 over 4, 28 over 4 minus 3 over 4, 25 over 4. Boom, done. Now I've checked it pretty thoroughly. I can check more if I want, but that took what, 5 seconds, 10 seconds? Now I move on confidently. Tip number 6, highlight every number and variable. Thank you, Karis. So we're talking about these word problems, right? If we look at something like this, what am I talking about? I'm talking about, every time I see a number, even in word form, you see that where it says twice, right? I've even underlined that. So anytime I see something numerical, boom, underline, underline, underline. And that's going to be really helpful for me not to miss information, but also to remember back, okay, wait, what does this mean again? Oh, yeah, the first time I underlined S was over there. Okay, S is the number of containers of fabric softener, et cetera, et cetera. So this is a really great tip. By the way, there are times on the SAT where you're going to underline a number, and it may not have anything to do with the problem. It may not relate. That does happen. It doesn't happen a crazy amount, but it does happen. Just want to let you know, but you should still underline it just in case. All right. And finally, tip number 7, know the distribution of difficulty. So this is helpful, especially if, let's say maybe you haven't done the amount of prep that you've wanted to do and you're taking it in a pinch and there's some things that you know and maybe you're a little shaky on others. Knowing the distribution of difficulty is really nice because, see, from 11 to 15, if you get stuck in that area, you're having trouble, boom, jump forward to 16, 17. Grab those easier problems because everything is worth the same. Grab number 18. Sorry, guys. A little tired. And the thing is, with the 19 and 20, sometimes 19 and 20 aren't actually that hard, but it's just more often than not they are. Even in 11 through 15, you might find question 13 out of the blue might not feel that difficult for you. But anyways, the main idea is generally this is how it's laid out. And it's the same with the calculator section. We've got these pockets like this. The reason why I'm telling you this is if you are in a pinch, make sure you get to 31 through 34 with enough time to answer them carefully and appropriately. So that's the idea. Even 35, 36 like that might be easier than 28 through 30. So that's it. Okay. Boom. We got this presentation out of the way. And now what we're going to do is we're going to do this one. Boom. Uh-oh. What's happening? All right, now we're going to go through these. Hold on one second. Okay. Now we're going to go through the formulas in question that are very, very important for you guys to know. Now, remember, we already talked about the formula that are given. So those ones, don't have to worry about them so much, but you got to know where they're at. They're at the beginning of each of those sections. Once you got that, let's look at the formulas that aren't given that you need to know. All right, here we go. And by the way, such that it's asking about tip 3, remember you can rewind and rewatch that part later after I'm done streaming. Actually, I think you can rewind right now, to be honest, midstream. So, all right, slope of a line. Here we go. The slope of a line is the difference of the y values of any two coordinates over the difference of the x values of any two coordinates. Right, here's an example. You have 2 points, 7, 2, 5, 1. So we take the difference of those y's, 2 minus 1, and over the difference of the x's, 7 minus 5. Now, does it matter in particular what order you go in? No, I could have switched it, but you have to be consistent. It's always one coordinate minus the other. One coordinate's the dominant one, if you will. So in this case, the blue one we've arbitrarily chosen as the dominant one. The slope is 1/2. Boom, done. Okay. Slope-intercept form. This is super important. Y equals mx plus b. This is the equation of a line where m represents the slope and b represents the y-intercept. So here's an example. We've got y equals 2x plus 7, We got a slope of 2 and a y-intercept of 7. You see there's your y-intercept at 7. And here's your slope. It's going up 2 over 1 for the win. Done. Let's go to point slope form. I love this. Whoa. This guy is being crazy. Hold on. Let's put this guy in timeout. All right. I don't know what's going on there. Okay, so point slope form. We've got, y minus y1 equals m times x minus x1. Okay. And in this one, m is again your slope, and your point is the point that you're putting in to create the equation for this line is x1, y1. Okay. And in this case, for example, down here, right, we'd have a slope of 3/2, and the point is 3/4. Again, it's the opposite. I know it says minus, but those are both positive. So we see the point 3/4, and again, we got a slope of 3 over 2. So that's point slope. It's great. And you can turn point slope into slope-intercept form by just doing this and then isolating the y, not the y1, but the y. So that's it. Midpoint formula helps you find the midpoint of any line segment. Check it out. If I know the endpoints of a segment, I plug them into this formula. What am I doing? I'm taking the average of the two x values at the endpoints, average of the y values, and that's the midpoint. Now, if I take an example, right, hey, what's the midpoint between 8, 4, 6, 7? Well, let's add them up. 8 plus 6 over 2, 4 plus 7 over 2. What you would get is 7, 5.5, right, once you average those out. So that's it. And again, that makes sense. We're trying to find a middle point, something in between 2 points. It makes sense to take the average of those 2 points. Number 5, distance formula. Excuse me. So distance formula here is x minus x2 squared plus y1 minus y2 squared. We're taking the difference of the x's, squaring it, difference of the y, squaring it, adding them together, square rooting it. This formula comes up mostly when you're trying to, let's say, like calculate the radius of a circle on a coordinate plane. It doesn't come up a crazy amount, but that's where I usually see this formula being needed on the SAT. So let's say we have these two coordinates, 5, 3, 1, 0. You plug them in to find the distance between the two. 5 minus 1, squared, that's 4 squared. 3 minus 0, 3 squared. So that is 16 plus 9. 16 plus 9 is 25. Square root of 25 is 5. That would be the distance. Boom, done. Let's go to length of an arc of a circle. All right, this is a really nifty formula. They do ask about arc length quite a bit. Arc length is like the crust of a pizza. It's that little red segment, right? And it's a piece of the circumference. Well, it's no coincidence that in this formula you see the 2 pi r for the circumference of a circle. And then you're taking a fraction of it. How are we getting that fraction? Central angle over 360, over the total angles in the circle. So we're taking that fraction of the circumference, that piece of the big pi, and there's the crust. Boom, done. All right, then we've got the rate. And okay, sorry, I'm reading some of these comments. Please talk about rate and the conversion formula. I really want to learn how to use it. Rate and the conversion formula. I'm not sure if you're talking about dimensional analysis, but dimensional analysis is kind of a case-by-case thing. It depends on what the question is asking, what the units are in, etc. But, okay, remind me near the end. Let me see at the end if I can think of how to just like generally explain it. I do have a video actually called the camp method, if that's what you're talking about. Google let me show you. I'm gonna just help this guy real quick. Yeah, here it is. So this is the video. If you're talking about I think you're talking about unit rate conversions, right? So I'll just post that for you. That was for Wizzy, I think. Yeah, Wizzy's Hangout. See if this video helps you out with what you're asking about. Okay, anyway, so back to this. Now we're into area of a sector. It's just like arc length, right? Because we're taking the whole area, but then we're taking a piece of it. We're taking a full slice of pizza. Again, no coincidence. You see pi r squared, area of a circle, and then we're taking that fraction based on the central angle out of 360 degrees. Boom, done. All right, sweet, whizzy, awesome. Glad that was the right one. Number 8, quadratic formula. Hey, what's up, Toe from the Ivory Coast? That's amazing. Yeah, okay, so Haroon, you're asking about the distance to find the radius. It can be if you know the coordinate of the center and a coordinate on the circle. Find the distance between those 2 points, that's the radius. If you're given the circle equation, which we're going to get to soon, there's another way to find the length of the radius. All right, quadratic formula. Famous formula, right? You know this to find the x-intercepts of a quadratic. I have a song. I would normally sing it right now, but I don't know if you can hear, but my voice is shot. It's like every morning now, my voice, I can't talk properly for like an hour or two, and then I can talk. So, I just woke up not too long ago and made my coffee and started the stream. I've been working like so late lately, every night. But yeah, anyways, so wait, let me try. Hold up. So this is the song. Yo, and give me a like if you haven't yet, because I'm about to sing. And my throat is kind of hurting. But you go like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's a song. Actually, it's a music video I have on my YouTube channel. So if you have trouble remembering this formula, you can think about that tune or that melody. Again, just search quadratic formula song on my channel and you'll find it. It's from way back in the day, but there's just a little tip for people who are trying to memorize this quickly, who can't memorize it. What's up from Nigeria, Nepal? What's up? Okay, so anyways, where do we get these values? B, A, C. It's from standard form, right? So we got ax squared plus bx plus c. You plug those in, and you get your x-intercepts. All right, here we go. Number 9, SOHCAHTOA. Here we go. This is all about trigonometry. And let's say if you have a triangle, you remember that sine of that little angle A right there is equal to the ratio of the opposite side to that, the blue side, over the hypotenuse. Hypotenuse is always opposite the right angle, right? The green side here. Boom. Cosine adjacent over hypotenuse, right? And that is the brown side. Again, it's relative to the angle, adjacent over that. And then... oh, thank you, Hassan. I'm going to show that. Thank you for that comment. I don't know why it got held. And then tangent is opposite over adjacent. Okay, so again, relative to the A, opposite blue, adjacent means next to, which is brown. I actually have a song for this one too. Not going to sing it. It's too much, but it's another music video if you want to check those out. It's on the main YouTube channel page. You can see all the music videos for different concepts. Okay, oops. There we go. Number 10, probability. Probability is the number of favorable outcomes over the total number of outcomes. That means if I want to know the probability of rolling an odd number on a die, okay, it would be, well, how many numbers are on a dice? 6. So that's the total number of outcomes. How many of those are odd? 1, 3, 5. 3. So my probability of rolling an odd number is 3 out of 6, reduces to 1/2. Boom, done. Okay, number 11, the circle equation. Here we go. It's x minus h squared plus y minus k squared equals r squared. What is hk? Hk is the center. So if you get this, and remember I was saying somebody is asking me another way to find the radius. So if you get it in this format, the center is hk, whatever is in those parentheses, and the radius is the square root of whatever value is on the right-hand side. So for example, if we have this as our equation, the center would be 2 comma negative 5. Again, it's the opposite. That's why that 5 is a negative 5. And then the radius is the square root of 36, which is 6. All right. Boom. And guys, if you could, please not use profanity in the chat. I would appreciate it. Okay. So exponential growth. Here we go. And this is growth or decay, to be honest. If you look at this equation, you want to know that A is your initial value. It's your starting value. So let's say we have a bacteria population. It's growing exponentially. The population starts at 5,000. A would be 5,000. Boom. R is the rate at which it's growing. Hey, it's doubling every day, right? 100% it's growing. Then you plug in 1 for R. It's growing by 5% every day. You plug in 0.05, whatever. And when it's growth, you're adding it to the 1, right? So, oh yeah, by the way, that's your growth rate. T is the time, and we'll get to that too in a second. But let's do a little example. So here we go. We got an initial value of 200. We got 13%. So again, it's growth. Growth at 13%. We're taking that 0.13 and we're going to add it to 1. We'll talk about decay in a second. And then your time, let's say, well, how much is it going to grow in 3 years? Well, let's take a look. 1 plus 0.13 to the third power times 200. Plug that in your calculator. Boom, you'll see what you get in 3 years. Now let's look at exponential decay. Let's say we have an initial value of 150, and now we're losing 9%. It's decaying by 9% every month. So in this case, we would simply subtract 0.09 from 1, okay? Again, time is 2 years. So we get 150 initial rate times 1 minus 0.09 to the second power. That would give you 0.91. And that makes sense, by the way, because that's 91%. That's what you have left when you lose 9%, 91%. Boom, done. Okay. Vertex of a parabola. So if we have ax squared plus bx plus c, we got negative b over 2a. Where is the vertex? It's either the high point or the low point of a parabola. It's a really important thing to know on this test. So if it's in standard, you need to find it. You can plug and chug. You can also put it in to vertex form, but that takes a lot more time. So that gives you the x value. Then if you want the y value of the vertex, you take whatever you get here, plug it in, boom, done. Okay, vertex form, here we go for a parabola. So vertex form is this, a times x minus h squared plus k. When you see a parabola in this format, it's really cool because the vertex is readily seeable. Like you can see the vertex, it's whatever h comma k is. Again, you see the h is flipped. It's minus h, but it's positive h. And then the k is positive. It is as it is. Does the vertex of a parabola equation, sum of solutions equation, always work? Yeah, of course. Yeah, they do always work. Okay. We're going to talk about sum of solutions in a second, by the way. So that's your vertex. And by the way, the A is important too because A tells you whether the parabola goes up or down. It opens up if A is positive. It opens down when A is negative. Okay. Pythagorean theorem. Now, this is an interesting one that I included because it's given to you on the formula sheet. But I put it in anyways because I just feel like it's such an important formula. So the Pythagorean theorem is a squared plus b squared equals c squared. If you have any right triangle where a and b are the legs, right? They're just the not the longest side, essentially. And they meet and form a right angle. And then you know that c is the hypotenuse, is the big dog. It always has this amazing relationship. So you can find it to find missing side lengths of a triangle, etc. Whoops. Okay, next, a simple formula, but an important formula nonetheless. Distance equals rate times time. So somebody was asking about rates and unit conversions. I really feel like this is at the heart of those unit conversions, is just recognizing this quick formula. Oh, they're trying to find rate. I'm kind of confused what's going on. Let me just, oh yeah, distance, time, boom. You know what I mean? So this will show you that you have to do distance divided by time, etc. Starting from this amazing formula. So anyways. Distance is D. Oh, wait, somebody's asking, when will I solve difficult questions? Well, difficult questions, I just did 2 days in a row of solving really hard SAT math problems. Here, let me show you those live streams right now. 1 second. I need to make it into a playlist, actually. 1 sec. Why is this not working? Here we go. Videos. Oh, it's the lives. 1 sec. Yeah, so this one. Give myself a like. Why not? Okay. This one is from yesterday. And then I also have this one from 2 days ago. Okay, there it is. So if you want to see me solving some hard problems, check those out. Okay, anyways, distance equals rate times time. Once again, d is distance, r is rate, t is time. Okay. Now, number 17, sine and cosine. This is a very interesting relationship that you got to be aware of, and they love to test it. So what does this mean? It means sine of an angle equals cosine of its complement, meaning whatever adds up with it to be equal to 90 degrees. So for example, sine of 10 equals cosine of 80, sine of 20 equals cosine of 70, etc., etc. So these are just a bunch of examples, but this is a great one to know. Again, I don't know why, but the College Board loves to test this. What's up, everybody in India? For those of you watching, I don't know if you guys know this, but I'm Indian. I speak Gujarati. Well, not really very well, actually, but I do know Gujarati, and it's cool. It's awesome. All right. Oh, somebody's asking about the unit circle. I will go over the unit circle. So here's the thing that I've always said. You don't need the unit circle because there's always workarounds. But recently in the last year, I've seen two different questions where if you do know the unit circle, it is a little bit easier. You can go straight to the answer. So I'll go over it at the end. Actually, let's do it right now. Hold on. Where is, let's go like this. 1 second. We're going to go to my Instagram page. I just did it. Okay, so let's talk about the unit circle. So, Gujarati, what's up? Awesome. Okay, so here's the unit circle. And the way that I see it come up is pretty straightforward in the SAT. They'll be like, what is sine of 3 pi fourths? Or what is sine of 135? Whatever. I think I remember radians recently. So they'll say, what is sine of 3 pi fourths? If you remember on the unit circle, sine is these y values, right? So sine of 3 pi fourths is just square root 2 over 2. Cosine of 3 pi fourths would be negative square root 2 over 2. And then tangent is going to be the ratio of these two. I feel like tangent is tested less. Maybe it may not be totally true, but I'm pretty sure. I feel like that's my sense. And the sine and cosine are more often tested. Here's the thing, though. I don't want to freak you guys out. Like, there's so much, it seems like, to memorize on this unit circle. And if you don't know it, it's totally fine. Like, you can still figure it out by creating a triangle using a reference angle. Oh, they want 3 pi fourths. What's the reference angle? It's pi fourths. It's the distance to the axis. So again, you're just like, hey, I can just find cosine of pi fourths, which is 45 degrees, make your triangle adjacent over hypotenuse, whatever, do your thing that way. And that's totally fine. It might just take a little bit longer. But anyways, that's the unit circle. That's the quick overview. If you have it memorized, great. Cosine are the x values, sine are the y values. If you don't, I wouldn't do it. Don't spend the time. It's too much. What's up from Jamaica? Yeah, just use SOHCAHTOA. Exactly. Okay. Back to this. Sum of solutions. This was for a quadratic. This is an amazing shortcut. If you're like, hey, this quadratic equals 0, what is the sum of the solutions? Okay, 1, you can find the solutions, add them together, boom, done. It's, of course, an option. But if you want like a ninja shortcut where you can roll in and just solve this question in 2 seconds, they're like, oh, they want the sum of solutions? Boom, negative b over a. That's it. So, for example, if this was 2, that was 4, that was c. The sum of the solutions would be b, which is negative 4 over 2, right? A was 2, I said. So negative 4 over 2, negative 2, that's the sum, boom, done. All right. Next, here's an example, sorry. So I got 2x squared plus 7x minus 5. The sum of the solutions is negative 7 over 2. That's it. The discriminant, very important. So if we have a quadratic like this, the discriminant tells us very interesting things about the nature of the roots or solutions in this case. So the discriminant is b squared minus 4ac. It's part of the quadratic formula. It's the piece under the radical. So if you know the quadratic formula, you know this. This comes up when they're like, hey, what are the nature of the roots of this solution, of this equation? Well, if the discriminant, like in this case, is negative, right, that would be 9 minus 40. We would say there are no real solutions. 2 imaginary, but really, for the purpose of the SAT, no real solution. if the discriminant is exactly 0, like in this case, right? That means there's one real solution. It's going to have a multiplicity of 2, but that doesn't matter. They're not going to ask about that. But you're going to have one real solution. That's it. One value that hits that x-intercept. And last but not least, we have it being positive. This means we have 2 real solutions. Another thing they might ask is be like, hey, what is the value of b? Or they might have k or something as a constant. What is the value of k so that there is at least 2 real solutions or 1 real solution? So they say like 1 real solution, you plug everything in with the discriminant, set it equal to 0, and then solve for that k value or whatever. That's pretty common. Hey, Bahrain. Yo, that's amazing. I've been to Bahrain twice. My uncles have a business in Bahrain, and I love that country. I haven't been there since 2009, but the first time I went, I was actually 13, and I went there it was the first trip internationally I took by myself to go visit my uncles. It was so much fun. I was in Bahrain for 3 weeks, and then I went again in 2009. So, such a cool country. Okay, anyways. Next, number 20, area of an equilateral triangle. Hey, and the same trip, by the way, when I was 13, yes, I'm Gujarati. The same trip, I went to the UAE as well, to Dubai and Abu Dhabi, but this was a long time ago. I think it's very different now. Anyways, all right, area of an equilateral triangle. This is kind of a pretty cool formula. Again, it's not so critical, but it's nice if they do ask for the area of an equilateral triangle, which is side length squared times square root of 3 divided by 4. But if you don't know that, what you can do is you can drop an altitude from the top vertex down, and you basically create a 30, 60, 90 on the right and left-hand sides. And you can still kind of piece together the area by finding the height, which is half the bottom length times the square root of 3, boom, boom. And you can still piece it together. But this is a nice little nifty formula, saves you some time. So for example, side length's 1, it'd be 1 squared times square root of 3 over 4. If the side length is 2, it'd be 2 squared or 4 times square root of 3 over 4. And when it's 3, 3 squared or 9 square root 3 over 4 would be the area. 21, Pythagorean triples. So these aren't formulas per se, but these are great to know. They test this a lot on the SAT. Probably the most common one is the 3, 4, 5. Another possible common one is the 5, 12, 13. Less common is 7, 24, 25, and 8, 15, 17. But the important thing, hold on, somebody's spamming. 1 second. The important thing is that we've got the multiples. They come up a lot, like 6, 8, 10, 9, 12, 15. These ones come up a lot on the SAT. You can also have multiples of 5, 12, 13. So do you have to memorize all these? No, but be aware, because it can save you some nice time when you're like, oh, this one's probably a 3, 4, 5 or 5, 12, 13. And it can help you just basically move faster and be more efficient. Okay, 22, perpendicular slope. By the way, when 2 lines are perpendicular, if one has a slope of a over b, the other one has a slope of the opposite reciprocal negative b over a. So here is a line with a slope of 2/3. Perpendicular would be a line with a slope of negative 3 over 2. Just as an aside, parallel lines have the exact same slope. So if one line has a slope of 2/3, the other one will have a slope of 2/3, but they need to have different y-intercepts. That's it. All right, finally, this one, I put it on here just in case you needed it in a pinch to be like, wait, how many angles, what do the angles add up to in a quadrilateral again or something? It's not like so much where they're doing like pentagons or hexagons or things on the SAT, but it doesn't really happen. But I threw it on here just at the end, just as a nice little formula to have in your back pocket. If you do forget that, actually the angles of a triangle being 180, that's given on the formula sheet. But for a quadrilateral or something, or if it does come up, this is the formula. It's the number of sides minus 2 times 180. So for example, a triangle, 3 sides, 3 minus 1. 3 minus 2 is 1 times 180 is 180. Got to know that, but that's given again. For this one, 4 minus 2 times 180 is 360. That's for a quadrilateral. And then for a pentagon, 5 minus 2 times 180 is 540. All right. That's it, ladies and gentlemen. Hey, Hussam, thank you so much. I'm so glad you love the channel. Hey, guys, you're welcome for doing this. I'm going to do this every time now. So if you're taking it again in March, we're going to do another study session in March. And that's it. Look how many people are here. This is so amazing. What I love to see as well is you guys are just coming here of your own, studying on your own because you're driven, you're on it. You know, it's such a cool community that has sort of came out of this YouTube channel. And I can see it here. I can see it in the Discord community. And it's probably the most important characteristic you can have, I believe, to be happy and be able to get what you want is that grit, that work ethic, the ability to just show up and push yourself. And you guys are proof of that right now. And I really can't wait to see how you guys do on the test tomorrow. I hope you guys will let me know and keep me in the loop. But I wish you all the best of luck. So I'm going to try and answer a couple questions. Yes, this will be posted as a video. This is going to get posted. Amazing. You want some quadratic? Nah, that's about all I can. Now I can say more than that, but not a lot. System of equations. So here's what I'll say, Niket. If you want to see that, watch like one of my recent walkthrough videos, and you'll find a system of equation problem. I think even here. Let me see if I've got, here, I'll show you where there's some good resources. Solving the hardest SAT math problems. I think this is a pretty popular video that I'm about to show you. Yeah, this one.
Now what?
Okay. The timestamps didn't totally work, but I'm going to post this. And I'm pretty sure, but you can see down here, I'm going to show you. Where's system? You can see all the categories. Yeah, like, look.
This one is pretty tricky.
Oh, wait, not this question. System. Where would have said your system of linear equations? These are also word problems, but
get the y-intercept. So the answer is C, and we're done. The system of equations.
Okay, so here's an example of a system. If you want to look at this video, and here, I'll timestamp it for you. Nah, I think this is it for streams today. I think that's it. Oh, similarity and congruence rules. That's in my other video. By the way, if you also want to, we have also another video course, by the way. It's in the description link below. If you want to buy it, you can literally buy it and cancel it today. It's only $15. There's 4 additional math practice tests, and then all these things like the formulas, the things that people are asking about in terms of what was it called, similarity and congruence. That's all there as well. So definitely check that out if you guys want to. Like I said, in the description link below. It's awesome. Okay, then let's see who you were asking about similarity and congruence. I believe that's here. So I'll timestamp it for you guys as well. Yeah, here it is. Boom. All right, there it is. Okay, guys. No, I do not believe that the international SAT is tougher than the regular one. I think people feel like that, but I'm not sure that's warranted. Okay, ladies and gentlemen, this is it. I wish you guys all the best of luck. I got to go. I don't know what's up with my voice. Like I said, it happens in the morning. So that's it. Thank you guys so much for joining. If you did like this video, make sure to click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you. Good luck tomorrow. You can do this. You're going to do this. And let me know how it goes. Have a great day. See you guys next time. Take it easy.